Hello. Good evening, Kashilingam sir. Hello.
Yes, sir.
Hello. Sir, can we start this? Good evening, Kashilingam sir. Kanchan, madam, am I audible to you?
Yes, sir. Yes, sir. You are audible. Hello.
Okay. Manjula, madam, am I audible?
Yes,
Madam,
sir.
am I
Yes, sir.
audible?
You are audible.
Ma'am, Kashilingam is in line, ma'am.
Yes, sir. Yes, sir.
Kashilingam is co-host.
Yes, sir. You are audible.
Thank you, thank you. Please mute, ma'am.
Okay, sir.
Kashilingam sir.
Yes, sir.
సరే అందరు చంద్ర
Kashilingam sir, am I audible?
అయ్యా ఆడియబుల్ సార్ ఆడియబుల్
Can we start the session, sir?
ఇంకా వెయిట్ సార్
Okay, okay.
இது என்ன பெருசா வர மாட்டேங்குது இங்க வரவை பெருசா சரிங்களா போய் பண்ணணும் ஓ அதை பண்ணணுமா சாரி சார் சார் ஒன் செகண்ட் சார் ஐ வில் கம்
Yes, sir.
okay be ready sir I will come
Yeah, yes, sir.
அதான் போடணும் மோப்பா
Manjula, madam.
Yes, sir.
Sir is ready. You can
Yes,
just
sir. Shall I
welcome
start,
for one
sir?
line. No, ma'am. 1 minute.
Okay,
Sir is not good for me.
Okay, sir.
Kanchan, madam. Manjula, madam.
Yes,
Hello.
sir.
Yes, sir.
Kanchan, madam. Whenever the participants entered in the waiting room, you please admit all the participants to the meeting.
Okay, sir. Okay, sure.
Okay, because you are the co-host. Okay.
Okay, sir. Okay.
Okay, you can mute, ma'am.
Okay, sir.
மேல இருந்து கீழே வருதுலப்பா மேல இருந்து கீழே வந்து மேல போயிட்டே இருக்கு திருப்ப அது வர வைக்கிறது நேத்து ஒண்ணு அதுக்காக தேடுனே என்ன ஆகுதுனாப்பா சார் யூ கேன் ஸ்டார்ட் சார்
Manjula, madam, please start.
Okay,
ma'am.
sir. Okay.
Okay. Manjula,
Good
madam,
evening, sir. Kasilingam, sir.
yeah you can start madam you can start
Good evening, sir.
you can
Good
start
evening
madam
to everyone. No research is ever quite complete. It is the glory of a good bit of work that it opens the way for something still better. And this repeatedly leads to its own eclipse. So every day we are conducting some sessions relating to this continuously. So again,
Madam.
still repeatedly we are doing
Madam.
this to get more knowledge and research, sir. With this
Madam.
flow, I welcome Dr. Kasilingam sir for today's session on behalf of Sheshadripuram Educational Trust, Sheshadripuram Academy of Business Studies, and on my own behalf to this wonderful session, sir. Thank you, sir. And I also welcome all the participants for this session. I won't waste much time, so I will hand over the session to Kasilingam sir. Sir, over to you, sir.
Madam, you are logged in with 2 mail IDs, ma'am.
Yes, sir. I will cancel, sir, because the sound
please
was not
cancel
coming.
it
That's
one,
why.
ma'am. Kashalingam, sir.
Sir, Kasilingam, sir, you have muted yourself, sir.
Wait,
Please
ma'am.
unmute,
Okay,
sir.
okay.
Yes, sir.
Yeah, shall I start now?
Yes,
Sir,
sir. Yes,
shall I
sir. Please
start?
continue, sir.
Yes, sir.
Yes, sir. Yes.
Okay. So, good afternoon, my dear friends. So, let us come for the third day of mine. Okay. So, today I will be discussing about sampling. So, which is very easy, but many people they have a problem. Then many of the place people in a YOC, the audience may not know what you have done because you will be going very fast. What you are telling, people may not understand, so they will not ask question relating to what you are telling. But everybody they will ask questions on sampling because this is everybody's prerogative. Everybody they have some knowledge, so everybody will ask a question. How you are selected, why it is. So everybody will ask this one. So you have to write this sampling in the methodology chapter. Okay. So whenever we say sampling, it consists of sampling design, which consists of three aspects. So one is closed. So I think I have closed. Okay. So now, okay. So sampling design, which consists of sample unit and sample size and the sampling technique. These three things put together, we call it as designing. So first, we need to know what is a sample unit. Okay, we will go to sample unit. Okay, we will go to sample unit. Sample unit is one of the unit into which aggregate is divided into for the purpose of sampling. So which means each respondent. So you have to define who is your probable respondent. People who are living in this Tamil Nadu. People are doctors. Doctors having this much years of experience. Anything like that. That is your one sample unit. Who is your sample respondent? Okay. So that is called a sample unit. So the sample unit is the individual person, maybe single person or animal plant or product that is being searched. In a market research, sample unit is an individual person. Okay, so we have to define what kind of person we are looking for. That you have to define. Okay, so household, which means only one person in a house, that is a household. So first you have defined. Now when you have defined, the total number of people is the target population. Total number of such people, they are the target population. Okay, now, so now which means around there are doctors in Pondicherry. So which means probably 2000 doctors might be there. The total doctors is the target population. Now, having decided doctors, having decided customers, having decided investors, okay, equity investors, we may not know the target population there, but we can define equity investors. That is, they should have invested equity, or otherwise people who are trading in the market. That is the sample unit. So now the target
Hello.
Hello? Hello?
Hello. Sir, you are audible. You can continue.
Audible, sir.
No,
You can continue.
but some disturbance are coming. All others, please unmute. All others, please unmute.
Yes, sir.
Okay.
Yes, sir.
So whatever required only, please unmute unless otherwise required. Okay. Okay. Very good. So now we have defined the. Okay. So having decided the sample unit, we can find out the target population. Now let us assume that doctors are, so I am studying the migrant laborers from Bihar state and the West Bengal state. So now I need to have a list from which I want to select the people. So I am going to the that is Medical Doctors Association, IMA, Medical Association. So where from I am collecting a list. They are giving a list of doctors. That is called the sample frame. That is called the sample frame.
Hello.
Hello, sir.
Hello, sir. You have muted yourself.
No, muted
Kindly
yourself,
unmute,
sir. Yes, sir.
Okay, so now the Bihar National is the sample unit. The total people is the target population. Now I want to have list to choose. So the list I might be approaching the government labor department. So whoever registered. Okay. So the list provided by them is the sample frame. In this sample frame, okay, some mistake may be there. That is the frame. Okay. Only from that I'm going to select the sample list provided by them. So there they might have included some wrong people also. So that normally target population and the sample frame may same, but sometimes what happened in the list when they have registered, okay, some 1 or 2 West Bengal people also wrongly they might have stated as Bihar. Okay, when I approve them, they will say this one. So some people they might have left, people might not have registered. My target population is all Bihar nation. But in the list, some of the people might have left out. So the always target population and the list which we have may not be matching, 1 or 2 mistake might be there. But we are going to select the respondent from the sample frame. So you should choose a sample frame where, which organization, where from I can collect. So you should choose a place or the from where. So properly, so the list provided them should be more accurate. So such kind of sample frame you have to select. Then from the sample frame, you have to decide the sample size. Okay, so how many people you are going to select? That is the sample size. Then after deciding the sample size, how you are going to select? That is the sampling technique. Okay, so now, okay, now let us look at, now look at, wait.
Sir, hello. Sir, you have
Sir, you have muted
kindly
yourself, sir.
unmute, sir.
Please unmute, sir.
Hello. Sir,
Yes.
you have muted yourself.
Yeah.
Yes.
Okay, so, okay.
Yes, sir, you can
Yeah, I am
continue.
coming.
Yeah.
Sample frame. Now let me read a sample frame. Sample frame is a source material or device from which sample is drawn. Okay, from the list you are going to sum. That list is a sample frame. It is a list. It is a list of all those within the population to who can be sampled, which may include individual households. The sample frame is the list of all items in your population. It is the complete list of everyone or everything you want to study. Okay, so difference between sample frame and the target per sample, this one population is, the difference between population and sample frame is that population is general. So sample frame is specific. Okay, so from this list I'm going to select. Okay, then target population. Target population for a survey is the entire unit for which survey has to be done. So then the target population defines those units for which findings are meant to generalize. Okay, so the target population, is the entire population group that researcher interested to do. Right. For example, let me give one example. For example, if the researcher wants to identify approximately how many parents read article in their child's school or children's school newsletter. Okay, so how many parents see over their school they are having newsletter? How many parents they read? Okay, then the target population would be all parents. Okay, now I'm a researcher. I want to study. So how the parents reading the newsletters of their children. Okay, so now all the parents. Okay, is the target unit should be individual. Which will be serving as a sample frame. Okay, then one more, as I have stated. Okay, now for example, suppose I want to, my objective is to survey the estimate the household income of Bihar people living in Chennai city. Then all households of Bihar people are the population. Okay, the sample frame I might have collected from some organization. So which the list may contain household of other states also, one or two, some wrong will be there.
Hello. Hello, sir. Um, Hello.
Hello, sir.
Hello.
Hello.
Kasilingam sir, can you hear me? I think there is some network issue with the speaker. Hello, sir. Hello. Kasilingam sir, you have muted yourself. Kindly
Yeah,
unmute.
no, not madam. Connection lost. Connection
Okay.
lost.
Oh, okay. Network
Okay.
issues.
Coming.
Yeah.
Wait. Then I have to.
Share your screen.
I have to scan again. Yeah, I'm doing that.
Yeah. Whether there is an option, share screen. Yeah.
Okay. The top that the frame is going, so that is why it is disturbing me. I'm not able to see the full screen. So that is the problem, right? So sample unit also we have discussed. Okay, sample unit. What is this sample unit? And then sample size. Sample size determination is the act of choosing number of observation, okay, or replicas to include in a statistical sample. Okay, this is the important feature for any empirical study. Okay, so now we will go to the sample size determination, right? So probably you might have understood what is sample unit, what is sample frame, what is the target population. These are all the three things you need to understand. Now let me go to the. So let me go to the. That is the. Sample size determination, right? Sample size determination. Okay. Sample size determination. All right. So for determining sample size, we have one formula. So this is the formula given by Israel, used to arrive the sample size for the research work. Sample size n equal to z square into sigma square divided by e square, where z square is the z value in a normal distribution curve, which is nothing but 1.96. Then E is the level of precision or level of error, which is nothing but 0.05, 5% level error. So at 5% level, my Z value is 1.96, right? So if you put 0.1, then you have to put Z value 1.63. Okay, so these are all constant. So only the difference, see, all the people will be having this same value. So only difference is the sigma. Okay, only difference is sigma. Okay, what is this sigma? Sigma is the sigma square, right? Otherwise the variance, otherwise standard deviation square. Okay, so now how to find out? See, Z value is known 1.96, E value is known. What is not known is sigma value. Okay, now what is sigma? That is nothing but the standard deviation. Right. So from this formula, the sample size is influenced by the standard deviation. Now look at this one. This is on the top. When the standard deviation is more, sample size is more, simple, right? Standard deviation because equal to this one. Now, what is standard deviation? Now, for example, first person, he says, I like very much, very much. Another person, he says, I don't like at all, very worst. So, which means one person telling high, another person, which means the deviation is very high. So, then we cannot come to a judgment. We should ask some more people. So, that is why But everybody they say 1, then we need not go for more samples. So that is why the standard deviation influences the sample size. If the standard deviation is more, sample size will be more. Okay. Now, how to find out standard deviation? How to find out standard deviation? Normally, after pilot study, we will go for a main study. That time, we will be selecting the sample, right? For main study, we will be selecting the sample. So, we need to select sample size immediately after the pilot study. So, let us presume that, okay, so now, okay, so let us presume that sample size determination. Okay, here, okay. So now let us presume that I've collected pilot study. Normally you should do with the 30. Let us assume that I've collected with the 100, right? Okay. So now, now for example, okay, I'm taking five items, all right, for which data is collected, 5 items statement. So now this is the 100. Now for each item, I can find out the standard deviation. I can find out the standard deviation. I can find out the standard deviation, right? Okay, so how can I find out? Very simple. Okay, so now if I click this one, std okay, from B2 to B101, right? First is B1, B2 it is written, so that is why starting from B2 to 100 data, so 101 we have started with the 2. Okay, so like that we are first is name, that is why we are starting with the B2. Okay, we have 100, so we have 102 items. So my standard deviation is this much. Like that, I'm trying to find out standard deviation for all. For standard deviation for all. Okay. Now, see, I'm going to apply this standard deviation into the formula. Now, what will happen? If I apply standard deviation, okay, then my sample size is 1145, 1500, 1800, 965, 1009, 1400. Okay, like this it is going on. So now for each item, my sample size is different. So now I have to choose one common standard sample size. Okay, which one I can choose? Whichever is having maximum, that I have to choose. Now maximum I got here because here my standard deviation is more. So calculate standard deviation for all the item. Whichever item is having higher standard deviation, take that standard deviation and apply to that formula. Simple. Apply to that formula. So now here it is 1.08. 1.08, that is the standard deviation. Okay. So now if you apply into that formula, you will get some value, that is the. So now Okay. So now I will come later. Okay. So I will come to this later. Okay. Now we have done this formula and we have decided this one. So very, very simple. This you can do when population is not known, because we are not in this formula, we are not using any value for the population. So this you can use whenever the population is not known. All right. So now what is this formula? What is this formula? Okay, so the formula is though this person has used, but the formula is a derivation. Okay, so it is not a formula. Okay, yesterday I have told you. Okay, so the z. Okay, otherwise z value, t value. Okay, z value or t value. Okay, t value is nothing but okay, so I will be telling this one very often, right? So where we will be using t test, z test, f test, everything we will be using. What we will be using is that f is nothing but okay, x bar, x minus mu, that is x bar, right? X minus x bar divided by standard error. Otherwise, when you have a two mean, all right, for example, independent sample t-test, you will be having a two mean, one mean minus another mean, that difference divided by standard error is the t value, all right? So, for example, two groups, one group mean, another group mean, that difference divided by standard error is the z value. This is known. We will be using this one many times. We will be using many times, right? Okay. So standardized score where we will be using x minus x bar divided by standard deviation. That also we will use, and now we are going to tell. So now what I am using is okay. So now I am bringing this two here. So this goes here, the z multiplied with the se. So division. So yeah, x bar minus mu, x minus mu, or x bar minus mu equal to z into se. Now x bar, this is the sample estimate. This is the population estimate. Population mean. This is the sample mean. The difference between sample mean and population mean is the error. So error equal to Z into standard error. What is the formula for standard error? Sigma divided by root n. All right. So this we know. Now, okay, now this root n is troubling. So how to remove root n? If I put the square, okay, square root will go away. Okay, so now e square, z square, sigma square divided by this root n square, which is nothing but n. Root n, okay, so which is none. So now let me take this n this side. So if I take n this side, n equal to sigma square, the z square into sigma square divided by e square. So though we have used this formula, somebody has suggested to use this one. This is nothing but the simple derivation where the anywhere we will be using this logic. Okay, so t is equal to one mean minus another mean divided by standard error. Okay, so like the same, z is equal to mean, estimate mean minus population mean divided by standard error. Okay, so don't think it is one formula, it is nothing but a derivation. Okay, so now I think you might have understood. Everybody understood? All right, everybody understood this one? Hello?
Yes, sir.
Yeah, very simple formula. Okay, very simple formula. Now this I will come later. Now we have a power analysis. Okay, power analysis. By using power analysis, so we can decide the sample size. Okay, so when you know the population, n divided by 1 plus n into E square. Now suppose my population is 1451 divided by 1 plus n. So 1041 plus 1 into error is 0.05. Error is 0.05. So 0.05 square, which is equal to this much, which is equal to this much. So this equal to this one, 399.72. It can be rounded to this one. So this is the power analysis, right? This is the power analysis. The power analysis we will be using many times in the sample size determination. Now, if it is another one, whenever we use categorical data, whenever you have a success, failure, such thing, okay. So probability of using probability. So whenever you use okay, smokers, we are telling, okay, probability of smokers, probability of not any person. All right, we are trying to understand the smoking habits. So the probability of smokers and my Q. Now P is probability of smokers, probability of investment. So actually I have used this formula because small savings, when I take 100 people, so only this many people have invested. So that is the probability of people who invested. Other people probability are not invested. So when I take 100, this is the probability. Now 70.7 is my p value. Now my q value is 0.3. Okay. Now, so my t value is known 1.96. All right. My p value is it can be ranging from 0 to 1. It can be 0.1, 0.2, 0.3, 0.3 like that. Why my q value will be 1 minus p value, which means when my p is 0.5, my q is 0.5. When my p is 0.8, my q is 0.2. Okay. So now the difference, which is error, the error is 0.05. So here also all the values are known. All the values are known. Okay. So but okay, now p value we need to know. But even then, சார் இந்த ஒர்க் ஷாப் கிளாஸ் எடுத்துக்கிட்டு சாயந்தரம் பேசுவா சார் 8 மணிக்கு அப்புறம். Okay, thanks. Okay, now I told you my p is 0.1, q is 0.9. My p is 0.9, q is 0.1. Right. Now let us assume that p is 0.8, q is 0.2. 0.8 into 0.2, it is okay 0.16. If it is for example 0.9 into 0.1, okay, so which means what will happen? 0.09.
0.09.
So when I will get to the maximum value, I will get to the maximum value when my p is 0.5. Okay, so that is the maximum value I will get. So the 0.5 into 0.5, I will be getting 0.25. For all other options, you will be getting lesser value. Okay, this is the maximum value. So 1.96 square into 0.025 divided by 0.05 square. If you calculate like this, your value will be 384. So the maximum possible, especially when you use some categorical data, whenever you use a categorical data, okay, so you can read this one. When my standard deviation of the scale is 0.5, like that, if it is that situation. So you can use this formula. When you use this formula, your maximum sample size is 384. So this is the Cochran sample size formula for categorical data. Now, whenever we are telling some names, please remember. All right. So then, for example, when you use statistics, SPSS, where we will be using these people names, Cochran. Okay. So we will be using this gentleman in many places. which means his contribution is very heavy to the field of statistics. Okay, so you can quote his name in some places. So they ask for now. Okay, now. Okay, I'm going to use one more. This is also when the population is known. Okay, so Chrissy and Morgan, people used to say Morgan. Okay, so he has given sample size table. Now, when the population is 10, sample size is also 10. When the population is 15, like that he has given, like that it is given. Now, for 750, 254. When it is 2,600 population, 385, 335. Now, when the population is 75,000, 382. When the population is 10 lakh, 384. Now, so this is the maximum he has given. Okay, so now, as per Morgan, the maximum sample size can be 384. 384, right? So as per this formula also, maximum is 384. Okay, now we have used one more formula earlier. Now let me go there. Okay, now see, for example, okay, what we are using, three values, right? Z square into sigma square divided by E, right? Okay, now Z value 1.96, all right? So that is common. Let us assume that common. Let us assume that my standard deviation is 0.5. Okay, my standard deviation for variable is 0.5. Normally in a 5-point scale, you cannot have standard deviation more than 1. Okay, so normally it will be ranging from 0.5 to this one. Now, when it is 0.5, let me put it into the formula. 1.96, 0.05, error is 0.05. All right. So then if I find out this one, my sample size is 384. My sample size is 384. Now, suppose if my standard deviation is 1, if I make my error level is 10%, 0.1, my population sample size is 384. Okay, so now 384 is the magic number. 384 is the magic number, which means, so if you take that, that also I want to put it. Okay, so if you take Naresh Malhotra, he says, so 384 is the universal sample size. So anybody, if they have taken more than 384, that is acceptable. So no international journal will ask for sample more than 384, right? If you put a 300, 400, something like that, it will be okay. So 384 is considered as universal sample size. Very good. Okay, now we are going to touch upon some more, right? Okay. Now I'm going to show one software, one RAW soft, right? Okay, so now let me go to the internet. Okay, let me go to the internet. I'm typing. Little slow. RAO, raw soft sample size. Can you see raw soft sample size? Sample size calculator, rawsort.com. Okay, so now what happens? Margin of error 5% already done. Confidence interval is this one. All right. So suppose my population is 20,000. My sample size is 377. Suppose my it is not 20,000. Let me put 2 lakh population, 384. Okay, suppose up to 2 lakh, right? Suppose if your population is only 5,000, 5,000. When my population is 5,000, when my population is 5,000, okay, so up to 5,370. Now, not only this one, it is giving. Suppose, okay, when you take the sample size of 100, then your error is 9.7. When you take 200, when your error is this one. When you take 300 for this population, your error is 5.4. So the opposite is okay. So confidence level. Right. Okay. If you want to take 900 for 90%, you should take 257. If you want to take 95%, this one. So you have to take 93. If you want to take 99%, you should take 586. So that is what the rough sum. Very simple, right? You can write a rough sum calculator also. Okay, acceptable. Many people they have used this rough sum. Right, very good. So now we will go to the okay. So we will go to this we have seen. Now we are going for another calculator that is called power and sample, right? Power and sample size. Okay. So now let me go power and sample size. Okay. So new power and sample size calculator. Power and sample size calculator. Okay, here power and sample size. Okay, so calculators. Okay, so now, okay, so now which test you want to use? Now, if you want to use one sample t test, all right, so that one. If you click, okay, now it is giving. So now when you use one sample t test, 32 sample size is sufficient. So this will give a power of 0.8. So that is what normally we will have a power. Power is nothing but 1 minus beta. 1 minus beta is type 2 error. Beta is type 2 error. Okay. So 1 minus beta is power. Power, right? So this is a type 1 error alpha, right? Type 1. So 5% level. Okay, when my power is these two information always you should give. All right. So what is the power you want? 1 minus beta is the power. We want more power because 1 minus error. Error should be less. Okay, so which means beta should be less. When the beta is less, our power should increase. Power will increase, right? So now, okay, so now normally people these are all threshold level. 1 minus beta, otherwise power is 80%. Here type 1 error is 5%. For one sample t test and one side this one is 32 is okay. Suppose like that you can see all you can use. Okay, here many things they have given many calculators, So what you want? Manova, ANOVA, one for one way ANOVA, how much? Okay, so next minimum test. For all tests, what is the sample size required? It will tell. It will tell. So this is the power and samples. Power and samples. Right. Very good. So now we will go to the we will go to the other one. Okay. This we are seeing. Right. Now we will go to the Daniel Sofer. Okay, so you might have heard about the Daniel Sofer. So yesterday when I have shown when I have shown different E resources, that time I've talked about the Daniel software, which yes, that is the site where you can test the effect of moderation, effect of mediation, you can check. So this gentleman, he himself again, he has provided a lot of calculator for sample size, for many purpose. These are all great people. Daniel Sofer is a great gentleman. He has given a lot of statistics, lot of things for us. Okay, so sorry. So Daniel, okay, Daniel super calculator, danielsofer.com, free statistics calculators. Okay, so now if you see here, okay, so for what purpose? So for all other things they will give less. Okay, so they have provided many information statistical. Now we'll go to sample size. Under sample size for multiple regression, okay. So then let us assume that we will go for a SCM. For this one different SCM, okay, structural equation model you want to use. Okay. Okay. So now effects anticipated effect size. Now, what is effect size? Okay, so we said the mean, one mean, for example, we are going to compare two groups, something like that. Okay, so effect size is one mean minus another mean, that difference, divided by standard deviation of first group. That is the effect size. So normally the effect size will be 0.1. So desired statistical power, that is 1 minus beta. So that is the 0.8. Let us assume that you have a 2 construct. Then let us assume that 4 items. Okay, 8. So our probability is that is the error level 0.05. Okay, then we will see what is the calculate. This is the sample size required for sum. Okay, it says at 947. That is the sample size required for. Okay, so a minimum sample size is 100. Also, you can use. Okay, so recommended minimum sample size. So up to this one, because to this one, so they have put. But this is the recommended. Okay, detect effect. So these are all Daniel Sofer. Okay, so now Daniel Sofer is over. Okay. Okay, so now two things I want to tell. Two things I want to tell. Some people, for example, one gentleman, yes, his guide has asked him to take more samples. He has collected 200 samples, 2000 samples. Then when he has come, whatever analysis we put, it shows there is a significant relation, significant effect. Okay, so which means when all are significant, which variable influencing, which variable not influencing, it is very difficult to do answer. Then see, for example, now one person has asked me, he has given 814 samples. Even my correlation is 0.1 on 0.1 something, even 0.08. Imagine my correlation is 0.08 correlation value, not even 0.1. Then it shows there is a significant relation. But in schools we might have studied When it is 0.5 and more, there is a relation. If it is less than 0.5, there is no relation. Okay, if it is 0, there is no perfectly no relation. If it is 1, perfectly there is a positive, perfect correlation. Okay, so we are studied it should be more than 0.5, then only there is a correlation. But this will show even if it is more than 0.1, it will be significant. When your R square is 0.1, it will show there is a significant influence. So even for a small R value, small R square value, you will be showing that there is an influence, there is a relationship. Okay, people who do not have much knowledge, they will say that you are writing something joke. Okay, so but you are right, because it shows 0.1 in 1,000 sample size is 100. When 100 items are related, which means the significant number, that is what it shows. Okay, but you will be having a trouble. That is why don't go for very large sample size. If you have sample size more than 384, it is well and good. Okay, that is the universal sample size. Now, okay, now what different people have stated, especially for some and other things I have written, it is a critical issue in some, but sample size, but there is no consensus in the literature regarding the appropriate sample size for some. Some evidence exists that some models could be meaningfully tested even if the sample size is quite small. That is what we have stated. But usually n is equal to 100 to 150 is considered as minimum sample size for conducting some. That is stated by these people. So many. Some researchers consider even a large sample size, for example, 200. This many people. Simulation studies show that with normally distributed indicator variables, that is item, no missing data, reasonable sample size for simple confirmatory factor analysis or measurement model is n is equal to 150. For a multi-group modeling, for a moderator, the rule of thumb is 100 cases observation per group. Okay, if you have a 3-group moderation, per group 100, right? Okay, so still not over. Sample size is often considered in the light of number of observed variable, which means number of items. For normally distributed data, Pendler and Cho suggest ratio of as low as 5 sample per 1 item. Okay, so when the latent variable or construct is having multiple indicators, but widely accepted rule of thumb is 10 cases per indicator. Okay, so is acceptable. Adequate sample size according to Nunnally. He is a great gentleman, Nunnally, right? All are big people, whoever have stated, right? So now this is another rule of thumb. Okay, so normally the error is 0.05. Okay, and the power is 0.80. Okay, this is with respect to sample size. Now, if you have any question, you can ask about the sample size. Right? Do you have any question?
Participants, if you have any questions, please ask.
Good evening,
Please raise
sir.
your hands or put in chat box. Or you can unmute yourself and you can ask the questions.
Yes, ma'am, you are audible. Ashwini, right?
Yes, yes.
Yeah, do you want to ask the question?
Yes, sir.
Yes, ma'am, you can carry.
So, good evening, sir.
Yes, madam.
Sir, as you told in the Cochrane's formula, the sample size is 384, and even you told that if we are taking more sample size, nearly 800, we are going to face some problem. What might be the problem, sir? If we take, is it wrong?
No, I don't. Please ask again, madam.
So you told that the standard sample size is 384. If you are taking more than that, yes, it is acceptable. But if you are taking more, around 700 or 800, it will be a problem for us. What might be the problem which we need to face, sir?
No, that I have told you, no. That I have told you very clearly. Okay, what I have told you, anybody? What I have told you, what problem you will face? Anybody?
Correlation you told, sir.
No, if you run any analysis, okay, for all analysis, you will be coming to a conclusion, every variable will be influencing. Okay, ANOVA, there will be a difference, chi-square, there will be association, everything will get significant relationship. Yes? Okay, now if you run a correlation, right? So for if you run a correlation, you will get a R value. Okay, so what is the R value, madam? What is the range of R value?
0 to 1.
No, what is the inference? What is 0? What is 0.5? What is 1?
That means there is no relationship, significant relationship.
Let it be 0. Huh? Hello? Hello?
Yes, sir. There is some disturbance here.
Yeah, ma'am.
Okay, except that, madam, others please unmute, madam. Okay, now see, as per the statistics book, if your R value is 0, absolutely no.
Yes,
R value is 0.1, no. R value is 0.2, no. Up to 0.5, no. Above 0.5, there is a relation. Yes or no, madam?
Yes, sir.
Okay, but here when you run with the large sample size,
yes, sir.
Even when your correlation is 0.1, it will say that there is a significant relation.
Yes, sir. There is some relation. Yes, sir.
Yes?
Yes, sir.
Now, some people, they will ask you, how come 0.1 is significant?
Okay.
Hello? Hello?
Yes, sir. Yes, sir. I got it, sir.
That is it. That is it.
Okay. Okay, sir. Thank you, sir.
Thank you.
Participants, if you have any doubts, you can unmute yourself and you can ask the question.
Okay. So, if there is no question, I will go to the sampling technique.
Kamala Devi.
Yes, sir. Yes,
Ma'am, do you have any questions to ask?
yes, ma'am. Yes, ma'am. I want to ask.
Yes, ma'am, you can carry on.
Kamala Devi.
Yeah,
Sir, I have one question, sir. If someone is saying if population size is unknown, means then go for non-probability sampling. If it is known, means they are saying go for probability sampling. With how we can find whether it is a probability or non-probability sampling?
Madam,
Yes,
that we have not discussed, madam. Okay.
Yes, sir, I know, sir, but
we have not. No, wait, madam. You wait. Okay, you wait because I have completed sample unit and the sample size. Now I am going for a sampling technique now. Okay, so you have to wait, madam.
Okay, sir. Thank you.
Yeah, yes.
Thank you, ma'am. Participants, do you have any questions?
Okay, so now let me go to the sampling technique. Okay, so now if you see the sampling technique. Okay, so sampling technique are random sampling, non-random sampling. All right, so probability sampling or non-probability sampling. So under probability sampling, we have simple random sampling, systematic random sampling, stratified random sampling, cluster sampling. Then non-random sampling or convenience sampling, quota sampling, judgment sampling, and snowball sampling. Okay, so these are all the techniques available. Okay, now first we will try to understand before going there. So let me tell you what technique you have to adopt. You have to adopt the probability sampling, otherwise random sampling. Okay, that is what you need to adopt. You need to adopt. Okay, so you have to adopt random sampling. Okay, how to adopt random sampling? You should try to adopt random sampling. Okay, now when random sampling can be many random sampling are there, but all random sampling can be conducted with the lottery method or random number generation. Okay, so which means whenever you have 1,000 numbers, so now you generate a random number. Okay, you can generate random number with the calculator itself. Okay, so if you put some 1,000, okay, it will give different random number. Okay, note down. And the population also, you give some numbers, continuous numbers or some numbers. So whoever selected in the random number, you have to choose that person. You have to collect the data. So any random sampling is conducted with by using generating a random number or lottery. What is lottery? All the people names are written and put it in the box. You will put at random and you will say whoever names come, you will be approaching. Okay. So now whenever this is conducted, whether it is lottery or random numbers, you need to have total population. The population should be known. Then only we can write the names I can put, or you can put the numbers you can use. When the population is not known, then you cannot use the random sampling. Okay, then you have to go for a non-random. All right. Now there is a question. What question? Sir, people are saying that non-random is not acceptable, sir. Okay, but my population is also not known, sir. Okay, so for which we will be going for a multi-stage random sampling. Okay, so how I will explain later. All right, very good. Now, I want to tell few things instead of telling what is that sampling. You study what is that sampling, this sampling. But I want to tell few points very clearly. Now, for example, recently I'm receiving many theses from Manonmunium University, especially that Nagarkoil, that area, okay, Kanyakumari district. So they will say that there are 9 taluk, whether it is a bank customer, whether it is a self-help group or tourism, anything. They say that there is a 9 district. It is population is divided into 9 districts. This many people, sanitary workers they have done. So these are all the different taluk. Each taluka we have given this much. So they say that this is a stratified random sampling. So since they have given the 10% of the population, they say it is a quota sampling. So now here, both are wrong. Now, what is stratified random sampling? What is strata? Anybody can you tell what is strata? Anybody? What is strata?
Group, sir.
Layer, sir.
What is cluster? What is strata? What is cluster? Give some example. Hello? What is strata?
Sir, cluster will be homogeneous, sir.
Hmm.
Cluster.
Yes, right.
Homogeneous, homogeneous sampling. Whereas in the stratified data, it will be in a heterogeneous.
Okay. So what do you mean by heterogeneous?
Different parameters. Based on the different parameters, we are going to select the sample.
No, madam, it is not. When you have parameters, it is wrong, madam. See, for example, now I am going to study the satisfaction of one thesis. They say satisfaction of sanitary workers in Kanyakumari district. All right.
Kashalingam, sir.
Yes, sir.
So if you take a homogeneous means, if you want to select the population in particular state, then we can collect the data from the entire country. The different category of people will be there. That is good to be considered as heterogeneous with a different category.
Okay. Now I will tell. So now sanitary workers in the Kanyakumari district. Now he says that each taluka is a different strata. Now, with respect to sanitary workers, the condition of sanitary workers, they are different in different taluka or same? Or self-help group members, the habits will be different for different taluk?
Yes, sir.
Is it same or different?
Sir, cluster sampling will
No, please answer my question.
Different, sir. Different.
It will be different. It will be different. So for MBA faculty in Tamil Nadu, MBA faculty in Karnataka, will it be different or same?
Different, sir.
No, how come it will be different? So which means, can you say that in Karnataka they are intelligent, here no intelligent? Can we say like that?
No, sir.
Then how do you say there is a difference?
No difference.
So which means they are not two different strata. Okay, so which means they are homogeneous. Okay, which means strata sampling is not applicable there. Okay, so now there is no difference. But for example, okay, now let us assume that with respect to satisfaction, okay, so I take male and female, they are same. But with respect to cosmetic, I want to study cosmetic expenditure behavior. Then male group and female group are different. I can consider when I study this one, these two people are two different strata. Clear or not clear? They are two different strata, right? So now two different group, within that group, the members are same. Within the group, the members are same. Within female, we presume all are same. Within male, they are same. See, some difference will be there, not entirely two different people. Okay, so this is a stratified sampling. Okay, so now when this is not two different group, when the taluka people living in different taluka is not different, you cannot segregate into taluka. You should not do. When you divide into taluka and select, which means you are considering each taluka as a different strata. Okay, so that you are not supposed to do. Okay, so now stratified sampling, different group among within their selected group, homogeneous. What is cluster? What is cluster? Right. So there is a homogeneous group. Okay, all are homogeneous. All are homogeneous. All. Okay. For example, right. So now we say cluster. Right. Clusters are. So now textile cluster. Okay, textile cluster. So textile, or we have a textile cluster in Tamil Nadu, or automobile. Okay, this area and that area, two different. So migrant laborers. So here in Kerala, okay, so Perumbavoor and Chennai and Erode, all are same only. All are but same. All that group, this group, all are same. Okay, but within, okay, within, if you take Perumbavoor, people within that, some people will be from Bihar, some people from this one. Okay, so within group, within the cluster, some size will be more, some people will be living for less number of years, some people will be working in different levels. Okay, so cluster is across homogeneous, within heterogeneous. Strata is across different, within same, within same. Okay, so whenever you segregate into different strata, when you say whether it is heterogeneous or not, you need to tell specifically. Okay, very good. Now within the strata, you can fix, you say that they are different. So 10% of the population, then they say it is a quota. No, it is not quota. You are giving 10%, but you are choosing, when you choose randomly from the list. Okay, now two different group, this is different group, this is different group. Samples are drawn from here, samples are, each is a different population. We are considering like that. Each is a different population. Then we are taking some members from here, some members are from here. Both at random. Okay, you might be having 10% here, you might be having 10% here, no problem. Okay, that is not a quota, right? So what is quota is? What is quota is a non-probability. What is non-probability? Now, wherein, like a judgment, okay, like a judgment. So within the strata itself, you will say, we will take the people who are living near to my, okay, people living near to my, whoever comes to me, but same 10% quota, everything you are doing. Okay, when the sample selection is not random, then it is a quota. Then only it is a quota. So when the sample selection is not random, whether it is different strata or same cluster, whatever it is, when the sample within the each group, when it is not, whether it is you have done some purposive, right, one top only or lower only, or whoever comes, anything, when you have not equal opportunity for being selected, then it is a quota sampling. Okay, so now what is judgment sampling? Now judgment sampling, I want to study the doctors in Pondicherry. See, doctors is my population. Now the another major mistake they will do. Okay, so now in the title itself they might have put the, okay, so they might have put engineering colleges. Okay, so work these faculty in engineering colleges. Now, okay, so now they will select, they will say this is a judgment. Why judgment? Because I have fixed engineering colleges, no sir. But that is the population. You have defined the population. That is not your sample. Okay, so now all engineer employee, all staff members of engineering college is the population. So within the population, now when you define the sample unit, the engineering college is defined as a sample unit. So within that sample, within that population, when you select somebody, okay, so now another thing, so engineering colleges also, they might have defined people are having 5 years experience. So that is also, you might have given the scope, the population itself 5 years. Now, what is judgment is, now all the doctors, now to give a generalized opinion about doctors, you feel let us take dental doctors. Yeah, they will be having more experience. Their opinion will be better. Okay, so then you are selected for the only the dental doctors. You are deriving the opinion and you are giving the inference to the all doctors. All doctors. Okay, so which means in the sample selection, now population is different. Now in the population, when you want to select the samples, when you have used any criteria, your judgment, then it is called judgment sampling or purposive sampling. Okay, so we need to though the difference is very marginal, you need to understand very very clearly. Okay, so now you know all the sampling. Okay, so now I said you need to go for a random sampling. Random sampling is applicable only when it is a population is known. Okay, now many of the theses they will write we have adopted simple random sampling. How they have adopted? They will say I am adopted stratified random sampling. How they have adopted? They will not tell. Which means you have to tell from the population how you have selected the sample by using that technique. How you have selected? See, around 500 people are there. I have put everything into the lottery and I have drawn this much people, or I have generated random numbers. Then I have put the list. Then I have selected the 100 people or totally 1000 people are there. I want to select 200. So I want to select 5 out of 1. Okay, so which means 1 to 5, I have chosen 3, then 3, 8, like that I was going. Like that you have to tell. Okay, so now I am going to tell how my scholars they are doing. Because I am doing all my research they are doing on investors. How are they doing? I am going to explain. Okay, so now he is writing. Okay, so now my standard deviation is this much. So my this one is 431. That is the sample size, right? Okay. Now okay. So now the area of the study is restricted to the state of Tamil Nadu, because Tamil Nadu is a representative population. Everything they will write. When you are put without specifying any area, okay. So because you feel the investor perception retirement planning is common throughout India, so you will not specify within Tamil Nadu. You can put a general. So then in the India we have many states in which we are restricted to Tamil Nadu. Where we have chosen Tamil Nadu, you can write. Now they all investors, equity investors. That is the retirement planning of equity investors. Okay, otherwise anything, whatever it is, equity investors. Now in Tamil Nadu, there are 12 cities. 12 cities are there, or 12 corporations in Tamil Nadu, as on 2016. So in which 3 cities are taken: Chennai, Trichy, Coimbatore, were randomly selected for collection of data. So the cities were considered as the target area of data collection, as the equity investment more prevalent in this one. Okay. So now, okay. So now, okay. So now, okay. Now it is going back. That is all. Okay. Okay. So now, This is also going down now. So this also. So now city, 3 cities are taken. First stage. Okay. Then list of share broking firms operating in all 3 cities were collected. List of share broking firms, that is company name. List of share, so car B like that. So they should be available in all 3 cities. Okay. Now, from that list of broking firms, 5 firms are randomly selected. The selected firms are Integrated Enterprise, Sharekhan, HDFC Securities, Kodak Securities, Reliance Securities. Okay. So now 3 cities. Okay. In 3 cities, all the share broking firms from the all, but they should be located in all 3 cities. Okay. Now selected at random 5 firms. So list of branch offices of selected the companies of in all 3 cities were collected. Okay, so Kodak in how many, HDFC, this one. The total branches count are 91. Okay, so now out of the total branches in each city, 50% of the branches were randomly selected. So which means 91 out of 51 now 45. So out of that 45, okay, 50% in each place. So in Chennai, 33, Coimbatore 9, and because 8 branches were there, so 4. Okay, so now we have around 45. So now to attain the arrived sample size of that, okay, so we want to give 530. Okay, so 530 means, so how many to each branch? How many to each branch? So we have distributed. Okay, so which means 380 distributed to Chennai, 100 to Coimbatore, 50 to this one. So which means approximately, okay, so 530 we want to get. So now in each branch, how? Okay, so each branch I want to have this many. So in each branch, okay, the customers, okay, so we have asked the list from the branch. Then from the branch, okay, with the help of branch managers, okay, we have selected the, okay, so customers, okay, at random with the assistance of branch manager. Okay, so now out of this 530 questionnaire distributed, 499 questions were received, and out of that 492, the 22 questionnaires were found to be incomplete. So finally, 470 questionnaires were considered for the analysis. So as per the formula 430, okay, but the final sample we have used is 470. So which we feel comfortable. Okay, so say when the error is standard deviation is 1, 384 is sufficient, but since the standard deviation little more, the sample size is 434. So, but we used 470, which is above this one, right? So that is where, okay, so how this one, like this, see now the population may be indefinite when you look at the overall in Tamil Nadu. When you look at the each branch, number of customers of that branch is known. So from that we have to come down to that branch level, which means okay. So what you can do is why this much? Okay, in India, Tamil Nadu, how many branches are there? Okay, so from this you select number of branches, then approach that people. Okay, so find out the list. Then from that list you collect at random. Okay, that you can do. Now one more. Okay, so now what we have done, one more also, though it is convenience, we are trying to bring some kind of randomness. How we are bringing randomness? For example, you want to find out the retail consumer, retail superstore, that is a retail store. Then what happened? So you among the all retail stores, you select some retail stores at random. Okay, so at a random given day, you visit this one. Whoever comes, don't take from all. You take from person who comes second, who comes in 7th and 12th, like that at random. So don't impose your bias onto that. Select at random based on their arrival. Not everybody. Okay, after leaving gap of 5 or 3, so select like that. So in that way, you can bring random where. So though the population, all these things are not known, so we can bring randomness. So people, international journals, they will not say that this is random. They will say this is convenience, but some kind of randomness is there here. So they will consider for publication. Now here, though systematic, this is a systematic random sampling. 1, 6, 11 is a systematic random sampling, right? But the population is not known. Whoever visit, okay, so we are bringing the randomness. Okay. So this is with respect to sampling technique. Now, if you have any doubt on sampling technique, now you can ask me.
Okay, participants, if you have any doubts, you can unmute yourself and you can ask questions.
Now that madam has asked me doubt, now madam, doubt is clarified or not, I do not know. What about that, madam?
Yes, sir. Yes, sir. Kamala Devi.
Ah.
Yes, sir. Cleared, sir. But can you one more time? Can you explain about the quota sampling, sir?
The quota sampling, madam. Okay, so quota sampling. All right. So we have some strata. We have divided into some strata. Okay, but within this strata, okay, so we say that there are 3 strata group. Okay, so you want to select, okay, so by using some judgment or okay, some criteria or some attribute, something. Okay, so people who are living in that place, I will take that. Okay, so some attribute will be there. So based on that attribute, you will give some okay, for this attribute 10, for this attribute 10, like that you will fix. Okay, so then in selecting this sample, random is not there. Why random is not there? You have not given the equal opportunity. Random numbers you have not generated. So otherwise, for example, okay. So now I will take a small diagram. Okay, so which will give some understanding, right? Okay. So now some people are there. Okay, so now yellow, red, and blue. Okay. So suppose there are 18 people are there. I want to select 6 people. From the 8. Okay. So some gap or something. Okay, color, anything, whatever it is. Okay. So now, or they belong to different party, anything. Now, if I feel, so people belong to ADMK, people belong to DBK, so the behavior will be different, entirely different. Okay, so which means they are different strata. If I consider they are different strata, okay, so which means now 3 groups: yellow, red, and blue. All right, okay. So now I have to select 6, which means I will be selecting 2 from each group. Okay, random. So which means from yellow these 2, so red these 2, this one, right? Okay, which means this group different, this group different, this group different. Okay, so now each group I'm giving 2. I'm giving 2. Okay, so that I can get, because 3 groups I have. Okay, I want to have 6. That because we already know the sample size. Only the sample size how we are going to draw. So this is 2 to each. Okay, now we will go for a cluster. Now let us presume that all 3 groups are not different groups, all are homogeneous. Okay, ADMK party, Congress, this party, that party. Now all parties are same. All parties are same. No much difference. Okay, so now the party people also not different. Okay, so now what I will do is, okay, now I feel all groups are same. Okay, all groups are same. Then what I will do is, okay, I want to have, okay, some this one. So now all people, all same. Now if we select 2, this one, 2 people. Okay, so now Congress party out of 5 party, let me select 2 because all are same. So in that, here I want to have 6. Okay, I have taken 2. Then I have selected all. I can select all. Okay, because I can select all. Okay, so now if you want to have only, okay, so now if I want to have 2 groups, okay, you can select, it is not a different strata. So which means you should give equal to all, that equal or proportional. So we have selected 2. In that 2 groups, okay, so I can select 20%, 20% for each of them. That also you can do. Okay, so here normally in a cluster we will try to collect. There is no distinction whether this color, that color. Okay, so when you have selected this group, okay, from that you pick up 50% of people, 20% of people, like that. Now let us go for a, okay, so now let us go for a quota. How quota? Now, okay, so now the same arrangement, I feel, so this is the lower level people, this is the higher level people in the within this one. So these people, top people, okay, so they live near to me. Okay, so some criteria, they are living near to me, they know me. Okay, so let me select only those people, 6 people, those who are living, which means I'm not giving opportunity to these people at all. Okay, I'm selecting only these people. Okay, so which means, okay, I'm giving, okay, so quota only to those people. Okay, so I may not select all. From that I will select 20 people, 20%, anything like that. So here when I distribute, some percentage are given only to certain groups, not to the other groups, so the selection is not random, or other peoples are not left out. Okay, so people will be there because some attributes I have selected, attributes. So this is the quota sampling, right? You read further, madam, lot of examples here itself, a lot of examples are given, okay, how it is drawn, okay, like that. So 100 people, 50 responses from male, 50 responses from female, like that we will do. Okay, like that.
Thank you
Okay.
so much, sir. Excellent explanation, sir. Thank you so much.
Okay, next, anybody, madam? Okay.
Excuse me, sir.
Yes.
Here in the chat box, Mr. Ashok has given. So his topic is emergence of agri-entrepreneurship in rural areas with reference to Rayalaseema region. So he has doubt in sample size selection, sir.
What is his doubt?
Ashok, sir, please unmute yourself and ask, sir. Ashok, sir. Ashok, sir.
Ma'am, is
Okay. So now I have a very basic issue. So now in the title itself, I feel it is wrong because see, agri entrepreneurs in Rayalaseema are different from agri entrepreneurs in other Anandapur? Whether it is different or not?
Yes, sir.
Is it
Ashok
different?
sir, you can ask the question.
Is it, will it be different? Agri
Sir,
entrepreneurs?
Sir, Anantapuri. Hello.
Yes, tell me,
Sir,
sir.
am I audible?
Yeah,
Yes,
yeah,
sir.
audible,
Ashok sir,
audible,
you are
audible,
audible. You can
audible. Yeah,
continue.
tell me. Yeah. Yeah.
Sir, it is Rayalaseema region. It consists of 4 districts. Anantapur.
No, another, no, leave it another, say Rayalaseema. You take coastal districts. Okay.
Yes, sir.
So whether agri entrepreneurs in coastal districts are
Sir.
different from Rayalaseema districts?
Yes, sir. Different.
How?
Sir,
How?
Rayalaseema is a drought-prone area.
See, for example, how do you say drought-prone area? Okay. So agri entrepreneurs see almost in all place it is safe.
Sir.
Okay. So now you need to how. So when you want to specify Rayalaseema, you have to specify very clearly how Rayalaseema agri entrepreneurs are different from other districts. If you could not tell that, then putting in the title is not acceptable. Yeah.
Okay, sir.
Yeah. Now, so yes, sir. Tell me, sir. Yes, sir. Tell me, sir.
Sir, actually, my doubt is how to select the sample in the region.
Okay. So you know population?
Yes, sir.
You know population, right? Okay. So your sample unit is agri entrepreneurs, all agri entrepreneurs, right?
Sir.
Or you want to specifically define?
Sir.
Okay.
Whether the agripreneurs in the form of farmers or they are in industrialists.
No,
this
sir.
Is my doubt.
No, sir. I don't know. See, whether you are going to take all agri entrepreneurs. Okay. So you define sample unit. That is the number one. Then based on sample unit, collect the agri entrepreneurs from some government office. That is the sample frame. From that sample frame, you use random sampling. You can very well use random sampling, sir. What is the problem? You can use a simple random sampling. Okay. Don't divide into 4 different districts, sir. Okay. Because I feel whether it is Kadapa or Kurnool or Anandapur, they are not much different, sir. They are not much different. So don't divide into 4 districts. That is a different strata, something like that. Don't tell. Okay. So you can tell this is the all are for same. Then you can say that is a cluster from the Rayalaseema. Okay, you can choose all the 4 cluster. When you say cluster, all the 4 not necessary. You can choose 2 district, 2 cluster. You can choose 2 cluster in the sense you can choose Kurnool and Kadapa or Anandapur and Kadapa. Okay, if it is all same. When you say this among the 4, these 2 are different, sir. These 2 are different, sir. Then 2 different strata. From that strata, from within the strata, they are homogeneous. They are homogeneous. Okay, sir. So you can choose one among that.
Okay, sir.
Okay. So like that, then see, always in not one stratified means throughout this one stratified may not be there. See, for example, among the 4 districts, let us assume that Nellore, Kadapa, same. Kurnool, Anandapur, same. Let us assume that. Okay. Which means this is one strata, that is one strata. Okay. Now, within that, it is 2 same strata, which means the Anandapur and Kurnool are clusters. Same group. So, now what we can do is, we can choose one cluster there and one cluster here. Okay. So, one Anandapur one and Kadapa one. So then from that cluster, you collect the Kadapa people and then you choose at random. you choose at random. All right. So we can use that. Hello?
Okay, sir.
Okay,
Thank you, sir.
Yeah, very good. Then,
Excuse me, sir.
yes, madam.
Thank you
Yes.
so much, sir.
Sir, I have a question regarding sampling size and selection. So for MSME, my research topic is impact of
Madam.
Yes,
Okay,
sir.
so then everybody they started talking for their own. This one no end, madam. Okay.
Okay.
So
Okay.
now
Okay.
whatever based on discussion, because then everybody will start asking with respect to their own example, right? So based on discussion, okay, if you have any doubt on the discussion or sampling technique, you ask madam. All right. Okay, madam. Then everybody, okay, whenever I teach analysis for my this one, what is the analysis, sir? What is this one? That will be never end, madam. Never end. So that can be discussed one to one. Okay, anyhow, since you have asked, okay, you tell me, madam. Yeah, I will tell.
Sir, MSME, different kind of MSME are there. If we have to select the sample, whether we have to focus on one type of MSME, or can we collect different types of MSMEs as a sampling? Because intellectual property rights, impact of intellectual property rights, sir.
Now, MSME, under MSME,
okay,
right, madam?
Yes,
Whether the M is there, MS is there, another M is there, all three are different, all are same.
All three are different from micro, small, and medium.
Which means all three are different. All right.
Yes, sir.
So
Yes,
which
sir.
means three strata.
Huh. Oh,
Okay, madam.
Okay.
Three strata. Right. Okay. So within that micro, all are same. Within that, which means homogeneous. Right. Within the micro, all are same. Then you can choose some cluster within that. What is the three clusters? You can choose. Okay. So within micro, without going further deep, with see, we have a three strata, each strata 20% or 20 each. Hello? Or 100 each. Hello, madam?
Yes, sir, I'm listening.
Okay, you can use like that, which means a simple stratified random sampling. That's all, matter over. So when you consider these three are different strata, then you have to draw from each strata. You cannot ignore any strata. When you consider all are three strata. All right, okay. When you consider all are same cluster, then you can choose only one. Okay, consider one, because all are same. All are same, right, madam? You can choose one, you can choose within that one, you can collect. When you consider these three are different strata, okay, so then divide. Then among micro, there are 100 people, 200 people. Okay, so let us assume that I want to have a sample size of 400, right? So then you can choose, what you can choose is medium will be less. Okay, medium will be less. So you can allocate 20% for each. Okay, from the total, you can collect 20% each. Here also 20%. Here also 20%. Okay, but the selection should be random. Okay, so all micro, lottery, and select.
Okay, sir.
Okay, madam.
Okay, fine, sir.
Yes, madam.
Thank you so much, sir.
Okay, thank you, madam. Thank you.
Thank you.
Thank you.
Sir, there are a few questions in the chat box from the participants. I'll read out one by one.
Yes, madam.
If there is a sample error, whether we have to include in sample, or we have to ignore it.
What do you mean by sample error?
The question is from Megha Shamala. Megha Shamala, ma'am, you can unmute and you can ask your doubt, ma'am. Megha Shamala.
Hello.
Yeah, ma'am.
Yes.
Sir, if we have find any sample error.
What do you mean by sample error, madam?
Sir, from the whatever the data we are collecting, so all the respondents may not answer for the
No,
few
no, madam.
questions.
No, madam. You are going there, the other side. So when you go for analysis, what you have to do, you are telling, right?
Yes,
Okay.
yes, sir.
So now in the sampling, with respect, sampling means selecting the respondent. That's all. Okay, selecting the respondent, giving, and okay. So here the sampling error means the rejection error, the rejection rate. See, for example, when you are given 500, only 400, because it is random. So you might have chosen, so you may not know that person. Okay, so there will be a rejection rate. So rejection rate will be there. Now, whenever we got, after collecting data, after entering data, okay, some people, they have not filled, which is a missing data. Remove
Yes,
it.
sir. Yes, sir.
That is, we have already discussed, missing data, remove it. Or some people, they have not filled properly, unengaged responses, remove it. When there is an outlier, remove it.
Okay.
Apart
Okay,
from
sir.
that, what error you will have, if you ask, tell me, then accordingly I will tell.
Okay. Whatever you said, that is, I am feeling it is a sample error.
Okay, now, madam, this is, see, we have something called the error. Okay, so only for that, we are allowing 5% error, madam. Okay, we are allowing 5% error. So up to 5% error, okay, so that is why 0.05. Okay, 0.05, right, okay. So up to that, we are accepting, that is accommodated. So that is called the error, madam. That is called the error when we look at this one. Okay, so we have two errors. We are not worried about the, okay. So now, whenever we decide the sample size, the percentage of error allowed is accommodated. So we talk about E. What is E? Error.
Error.
Okay, so we allow 5% error. Hello? In the sample size formula itself, the error is accommodated. Both formula, whatever formula you use, we will be doing E, and we are using not only E, which is alpha type 1 error, some for SEM and other things, we are using the type 2 error also. 1 minus beta. Beta is a type 2 error. That is the power. All right. In a sample size, we have used power also. Hello, madam.
Yes, sir, you are audible.
All errors are accommodated when we decide the sample size.
Okay, sir. Thank you, sir.
Thank you, madam.
Thank you, ma'am. Sir, there is one more question. When the population is not known, what is the procedure?
I have already explained.
Okay.
I have explained very in detail. In the initial stage, population may not be known, right? Okay. For example, investors. I have taken so much time to explain. The investors not known, but I know the list of investors, list of customers of particular share broking firm is known. So now what I have to do is, so now I want to collect the investors, which means investors, they will invest through some share broking firm. They cannot invest directly. So all the investors, they have to go to the share broking firm. So now, among the all share broking firm, you select some share broking firms randomly. Then you collect the list from them. That list is known. From then, we take a sample at random. Okay. See, for example, all supermarket users. So all supermarket, the retail, you may not know. But there you may know this many supermarkets are there. Okay. So you select some supermarket. So from that supermarket, select the customers, ask them. You can use random there. Hello?
Yes, sir, you are audible.
Somewhere we can bring a population.
Okay.
That is the trick you need to adopt.
Okay.
Yes, madam. Anybody else?
Sir, another question is from Dr. Dharmaraj. Which formula to be frequently used in SD value?
What is SP value?
SD, sir, SD.
Standard deviation.
Yeah.
Ask him to talk to me, madam.
Okay. Dharmaraj, sir. Sir, are you there? You can unmute and you can ask the question, sir. Dr. Dharmaraj. Dr. Dharmaraj, sir.
Okay. So now anybody, can you give an answer to his question? What is the formula for standard? Which formula? Say there is only one formula for standard deviation. Yeah. How come there can be different formula? There is only one formula. Okay. But there are two formula, that is the population standard deviation, sample standard deviation. Here we are worried about the sample standard deviation. Otherwise, STD TV. Simply in Excel, I have shown STD TV standard deviation. That you put and select it, automatically it will come.
Okay.
Automatically it will come. I have shown. I have typed also there standard deviation.
There is one more question from SABS 403. For definite and indefinite population, the formula for finding the sample size. Only that much they have given. For definite and indefinite population, the formula for finding the sample size.
No, I have given, for example, okay, so if you look at the literature, they will do different formula. Okay. So, but as far as I am concerned, when the population is not known, which means indefinite.
Okay.
When the population is not known, the Israel formula. What is Israel formula? Z square into sigma square divided by E square. When the population is known, you go to Morgan, or otherwise you go to Ravsoft, or you go to Daniel, anything you do. You go to Ravsoft, you give the population, it will give this one. Why you worry?
Okay, sir.
I have demonstrated everything.
Okay, sir.
Okay, so I think with this we will stop. I thought of explaining one more also.
Okay.
One more that, but that will take a lot of time. So whenever time is there, we will discuss. Okay, this I have already opened. Okay, so now for few minutes. Okay. So now, okay. Now when you look at the type of data, okay. Okay. Now I am going to show types of data. All right. One is called cross-sectional data. Another is called time series data. Another is called panel data. What is a cross-sectional data? Anybody? What is cross-sectional data? Anybody? Hello, anybody? What is cross-sectional data? Hello, anybody? What is cross-sectional data? All the people are there, madam. All the people left.
Yes, sir. Yes, sir. Sir, all are there.
No, but only 85, 83 people are there. But 250 registration I could see.
Yeah.
Okay.
Before it was 100. Participants, if you know the answer, you can unmute and you can.
What is cross-sectional data? What is time series data? What is panel data?
Like it is quantitative data where you can compare between two different sets of data.
Now, what is cross-sectional data?
So data collected over a short period of time.
Okay, so not short period of time, madam. It is a particular period of time.
A fixed period. A fixed period of time.
At a particular period of time. Okay.
Different observations, sir.
Across
yes, different observations of one particular area.
Okay. No, madam. Actually,
Set at a fixed point of time.
Wait. Okay. Now, for example, here 85 respondent people are there. If I collect the details today from these people about their income, age, what are they doing, where they are studying, which place. So I will be having a details about 85 people. I will be having details about 85 people. So that is the cross-sectional data. Okay. So now, for example, GDP of 100 countries for 2020. That is why particular period we are telling. Okay, so the GDP of 200 countries or 100 countries for 2020. This is a cross-sectional data. So that is why normally people say cross-sectional data, primary data, and the time series data, secondary data. No. For example, when you have a GDP, okay, it is a secondary data. But when you have a GDP for 100 countries, this is a cross-sectional data. What is time series data is, okay, so now one country, India, for the last 20 years, now you have a data, but data for different period. Now you might have collected now, but the data consists of period for last 20 years. That is a time series data. Now panel data is combination of both, combination of cross-sectional data and panel data, the time series data. Now I will show some data. Now people should respond. People should respond whether it is a cross-sectional data and time series data. All right, okay. At least somebody. Now let us see. It will take time. SPSS already opened SPSS. Okay. Now I have some data. This data also. Now, okay. So now I have some data open. It is okay. It is. Okay, now it is open. Right. Okay. So now can you tell what is this data? Somebody? Whether it is a cross-sectional or panel or time series. Hello?
Yes, sir, you are audible.
Yeah, I'm audible, but people are
Yeah.
It is cross-sectional data, sir.
It is a cross-sectional data because data, this is ID, data collected from section, age, their education level, their mass mark and other things. How come now some people are coming? Okay, so now this is a cross-sectional data because we have a data about this many people, right? Okay, so that is number one. Number two, okay, now let me go to types of data. Now, this one.
Ready?
Time series. Hello.
Yeah, tell me.
Sir, time series data, sir, because you have asked about the total income and total savings like that.
Anybody?
Hello?
Anybody?
It's a cross-sectional data, sir.
It is a cross-sectional data. All right. It is not a time series. So look at the data. 13,500 time series means today 13,500, yesterday 3,000, day before yesterday 6,000. Whether you can have this much variation?
No,
Not.
sir.
No, sir.
Okay, so now this one is the first person income, first person saving. This is the second person income. That is a particular point in time, right? So this is a detail about different people. This is a detail about different people, not for same people, different year. Okay.
Okay. Okay, sir.
Now I will ask something. Let me put open with open. So I will open. Okay, now tell me.
Time series data, sir.
This is a time series data. All right. Okay, this is over a period of time for one country. Time series data over a period of time for one country. Their expenditure, their all these things, right? Okay. So, know what I opened. Okay, so now types of data. What data?
Panel.
Time series, sir.
Time series only, sir.
It is a
Time series.
Time
Time
series.
series only. Very good. Now I'm going to complete, madam. Okay.
Okay.
This is the final one.
Okay, sir.
I should have used something I'm opening.
Panel, sir.
Panel, sir.
Oh, this
Sir,
is for different banks.
Banks.
This is
For
for
different dates.
Different dates,
Different years.
different
Deposits.
deposit amount, different income.
Okay, very good. Okay.
Thank
Okay.
you.
Now this is the panel data. Right. Very good. So I think with this we will stop. Okay. So I have to tell the nominal data, ordinal data, those things also. So tomorrow, if time permits, we'll tell. Otherwise, we will look into only the assumption checking as per the user. Okay. So okay. So thank you very much. Thank you.
So, thank you very much, sir. Indeed,
Yes.
you have given a deep insight into sampling design,
Okay.
how to select a sample size,
Yes,
and different sampling techniques. Everything you have covered, sir. So we have got very more knowledge on this sampling design and all. Thank you very much, sir. Thank you, one and
madam.
all who have attended this session. Thank you, one and all. Thank you.
Thank you, madam. Thank you so much. Thank you, madam.
sir.
Thank you,
Thank
thank
you,
you,
sir.
thank you.
Thank you, sir.
Thank you, 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 thank you.
Participants, feedback link is given in the chat box. Kindly go through it and you can give your feedbacks within 3 days. Thank you.
Thank you, sir.
Thank you, madam.
Thank you, sir.
I'm just closing.
Thank
now.
you, sir. Thank you so much.
Okay, thank you.
Thank you so much, sir.
Thank you, sir. Thank you, everybody.
Thank you very much, sir.
Thank you, sir. Thank you.
Thank you, sir.
Thank you. Thank you. Thank you, madam. Thank you.
Thank you, sir.
Thank you, madam. Thank you.
Ma'am, we are not able to find feedback form in the chat box.
It's posted, ma'am. The link has been posted. 1 second. It's there, ma'am, in the chat box. I'll post it once again. Now, ma'am, did you get it? Hello?
Right now we got it.
Yeah.